And welcome to this Python tutorial. So in the previous tutorials we did the big first step of natural language processing, which consists of cleaning the text we're dealing with, and now we are ready to the big step of natural language processing, which is to create the bag of words model. So first, let me explain what is the bag of words model and why we need to create it. And by understanding why we need to create the bag of words model, you will understand even more why we had to clean the text before. That is why we had to clean all our 1000 reviews. Okay, so first, let me explain what is the bag of words model. So, basically, in the first big step of natural language processing, not only we cleaned all the reviews, but we also created a corpus. And our corpus is here. We can have another look. That's the corpus containing our 1000 cleaned reviews. So it is from this corpus here that we are going to create the bag of words model. So the bag of words model, what is it? Well, it's basically really simple. What we're going to do to create this bag of words model is just to take all the different words of the 1000 reviews here. So we will take wow, love, place, crust, good, tasty, texture, nasty, and all the other words down to the 1000th review without taking twice or three times the duplicates or triplicates. We're just taking all the different but unique words of these 1000 reviews, and basically then what we'll do is to create one column for each word. So of course there are a lot of different words here, so we will have a lot of columns, and then we will put all these columns in a table where the rows are nothing else than the 1000 reviews. So basically what we'll get is a table containing 1000 rows where the rows correspond to the reviews, and a lot of columns where the columns correspond to each of the different words we can find here in all the reviews in this corpus. So each cell of this table will correspond to one specific review and one specific word of this corpus, and in this cell we're going to have a number. And this number is going to be the number of times the word corresponding to the column appears in the review. So for example, let's say that the first column corresponds to the word wow. Well, for this particular first column and for the first line that corresponds to the first review, that is this one, well, since wow appears once in the first review, well, we'll get a 1 in this particular cell because this cell belongs to the column that corresponds to wow, and wow appears once in the review. So we'll get a 1 for this cell. But then, if we stay in this first column but move on to the second row, well, since wow doesn't appear anywhere in the second review, we will get a 0 for this particular cell belonging to the first column and the second row. So as you can imagine, for most of the cells we'll have a 0 because we can simply see that with this wow word here, which will be one of the column, and we can see that this word appears in the first review, but when we have a quick look at the other reviews here, well, we can see that it doesn't appear much. So we'll get a lot of zeros for this first column, and same for this second word here, where love should be more relevant than wow and should appear more in the reviews, but still when we have a quick look at the other reviews, we can see that the word love doesn't appear much. So basically what will happen is that even if we create one column for each word, well, the word don't appear in most of the reviews, and therefore we'll get a lot of zeros because when the word doesn't appear in the review, well, the cell corresponding to the review and the word gets a 0. So we will basically get a table with a lot of zeros, and actually this table is a matrix, and a matrix containing a lot of zeros is called a sparse matrix. And the fact that we have a lot of zeros is called sparsity. And that's a very common notion in machine learning. We work a lot with sparse matrix, and we're trying to reduce sparsity as much as possible when we work with machine learning models. And you will understand why very quickly. Okay, so now that you understand what we'll get after creating our bag of word model, because creating this sparse matrix is actually the bag of words model itself. Well, the bag of words model is basically to simplify all the reviews, clean all the reviews to simplify the words and try to minimize the number of words. And it's also about creating this sparse matrix through the process of tokenization. Tokenization is the process of, taking all the different words of the review and creating one column for each of these words. So that's the bag of words model. That's what we get in the end when we are done with this creation of our bag of words model. So now that we understand what it is, why do we need to create such a model, such a representation? Well, it's because simply what we'll do in the end is to predict if a review is positive or negative. And for our machine learning model to be able to predict that, well, it needs to be trained on all these reviews, because for all these reviews, we have the real results. That is, we know for each one of these reviews if it is positive or negative. So we will train our algorithm on all these reviews because we have the results. So the machine learning model will understand how to make the correlations between the hints that tell if the review is positive or negative and its true result, whether it is positive or negative. So, it will make some correlations between the words that are in the review and the real result. So that's great. But in order for our machine learning model to be trained to predict if a review is positive or negative, well, as usual, it needs to have some independent variables and one dependent variable. Because simply what we're doing here is classification, because the outcome, the dependent variable, is a categorical variable, a binary outcome. 1 if the review is positive or 0 if the review is negative. So we are doing nothing else than classification. And as you saw in part 3, classification, well, we have some independent variables on which we train our machine learning model to predict the dependent variable, which is the categorical variable, most of the time a binary outcome. And that's exactly what we have here when we create our bag of words model, because each of the columns corresponding to one specific word is one independent variable itself. Because each of these columns, which are a word, are in some way connected to the reviews, because for each of the review we can say if the word appears yes or no in the review. And so when it appears in the review, the column gets a 1, and when it doesn't appear in the review, the column gets a 0. So this connection between the columns that are the words and the rows that are the reviews allows us to create a classification model, which are the exact same classification models we had been working with in part 3. So what this means is, as soon as we manage to create this bag of words representation with all the words in the columns and all the reviews in the rows, well, we win, because then we simply need to copy-paste our classification templates, and that's what we'll do at the end of this section. We will have our matrix of features, our matrix of independent variables, which will be the different words appearing in all the reviews here. That will be the columns of our matrix. And we'll have our dependent variable vector, which will be the result whether the review is positive, 1, or negative, 0. So that's why we need to create this bag of words model. It's just to obtain the standard classification model, and that's why in some way we are doing nothing new here in machine learning. We are just getting back to the classification part, but we are dealing with text. And so now we understand very well why we had to clean all the text, all the reviews. It's because since we create one column for each word, that is one independent variable for each word, well, we want to clean the reviews and simplify them as much as possible to reduce the total number of words in the corpus and therefore the total number of independent variables. Okay, so I hope it's clear. Don't hesitate, feel free to ask any questions in the Q&A if it's still not crystal clear. And now we will move on to the creation of our bag of words model by creating this huge sparse matrix, putting each of these 1000 reviews in its own column. And we will do that through the process of tokenization, And finally, once our bag of words model is created, we will be able to apply our classification models to predict for each new review if it's positive or negative. All right, so let's do it. Let's close this. And now let's create our bag of words model. So, as I just said, we will create this bag of words model through the process of tokenization. And of course, you can imagine that if we had to do it by hand, well, it would be quite complicated. So of course, we will use a tool that will do that in 2 lines, and this tool is going to be the Count Vectorizer class. So we will import it right now. We are importing this class from sklearn.featureExtraction. Here it is, enter, .text. Here it is again, enter. And now we import the class that we need, which is Count Vectorizer. Count Vectorizer. Okay. And now, as usual, since it's a class, we will create an object of this class, and that is this object that will proceed to the tokenization, that is, to the creation of our bag of words model. You'll see that we will only need 2 lines from now, 1 line to create the object, and 1 line to proceed to this transformation, that is, to this creation of this huge sparse matrix. All right, so let's do it. Let's start by creating the object. Let's call it CV for Count Vectorizer, and equals. And so, as usual, we need to call the class again, copy, paste, and add some parentheses. All right, so at this stage, we don't need to input anything in this Count Vectorizer, but we should have a look at all the parameters, because you'll see that there are some very interesting things. So I'm pressing Command I here to inspect Count Vectorizer, and let's have a look at the parameters. All right, so as you can see, we have several parameters, but the one that I want to highlight here is this one, stop words. As you can see, we have this stop words parameter, which, as you might have guessed, remove all the words that it will find in the corpus, because we will then apply our object with the fit transform method to our corpus that we created here. So if we add this stop words parameter in this Count Vectorizer here as input, well, it will automatically remove all the stop words in this corpus when we apply the object to the corpus. So that's not bad, that's noticeable. And we can even have a look at other parameters like lowercase. Well, that's the same. If you add a lowercase parameter in this Count Vectorizer here, well, what happens is that when you apply your object in the fit transform method to the corpus, it will put all the reviews in the corpus in lowercase before creating this huge sparse matrix. So what do we have next? Do we have other interesting things? Well, if we go up again, I saw token pattern, that is interesting as well. And basically token pattern is what we have done here, you know, by taking all the words that have letters from A to Z, removing other characters. And that's because this is the parameter token pattern, and the pattern is actually what you want to keep in the reviews, as in the letters from A to Z. So basically what I'm showing you here is that what we did here, cleaning the text manually, well, there are some options that we can do directly in this Count Vectorizer by playing with these different parameters. But this is not the best way to do it. And there are 2 reasons why I prefer to proceed this way. The first reason is that we get to see how to clean the text step by step. So that's for teaching purpose, but that's not all. Here, by cleaning the reviews manually, that gives you more options. You know, this Count Vectorizer has several parameters that allows you to clean the reviews automatically by playing with the parameters, but sometimes you will need more than that. Sometimes you will need to do further cleaning to clean whatever text you're working with. And I can give you an example. Let's say you are doing natural language processing to do web scraping. Well, in that case, the texts are going to be some HTML pages. And in those HTML pages, you'll get some HTML code, like BR, for example. So even if you use this code here to keep all the letters from A to Z, well, you'll keep this BR anyway, whereas you want to remove it. So you would need to add another option to clean these HTML tags. And by the way, if you want to do that, you can ask me some questions in the Q&A and I'll tell you the code to remove these tags. But basically, doing this manually here gives us more control and more options, and that gives us the possibility to clean fully the review as we want. So you have a choice, and now you know that you also have this kind of shortcut here by playing with the parameters of Count Vectorizer. Alright, but now we won't input any parameter and we will proceed to the next sub-step of the creation of our bag of words model, because now we just created our object. So now what we have to do is apply the fit transform method from this CV object to our corpus of reviews. And what will this fit transform method will do? Well, it will do nothing else than creating this huge sparse matrix I've been talking to you about. So let's do it. Let's create this sparse matrix. So what we'll do is, since you understood that this sparse matrix is going to be nothing else than this matrix of features containing the different independent variables which we'll use to train our machine learning algorithm to predict the outcome of the review, whether it is positive or negative, well, we will call this sparse matrix X. Because when you remember part 3 classification, well, we used to call our matrix of features X. So X here, then equals, and now let's create it. So as usual, we start by taking our object, CV, then dot, and then that's where we use the fit transform method, because, you know, remember that our object needs to be fitted first to the corpus to analyze it, look at all the words, look at how to apply the different parameters we input in this count vectorizer. And then, of course, after it's fitted, well, we proceed to the transformation with this transform part here of the fit transform method. And of course, that consists of creating this huge sparse matrix, putting all the different words in its own column. All right, so now let's add some parentheses. Here we go. And of course, in this fit transform method, we just need to input what we need to transform, and that is the corpus. And that's all we need to input. We only need to specify what we need to transform, and this method will do the whole work for us. So that's great. But now we just need to add one little something. You know, remember in part 3 classification, we had a matrix for X here, because this is our matrix of features. So in order to have a matrix, well, we just need to add here dot and then to array. And we add some parentheses. Here we go. And that's all. We have our only 3 required lines of code to create our bag of words model, that is to create this sparse matrix. So right now I just need to select these 3 lines here and just press Command and Control plus Enter to execute. Here we go, sparse matrix created. And so we will analyze it and maybe improve it in the next tutorial.